Okay, there is here a list of functions of which we have to calculate this particular primitive, the integral from -1 to x. X is somewhere in between -1 and 1, right? There are two ways of doing this, right? I'm going to illustrate the two ways using the first function here, and then all the rest can be done with either one or the other method, all right? Okay, so let's try to do this, okay, with the first method. The first method is going to be the following. This function here is, the definition is different according to whether x is in the positive side or the negative side. So suppose that x is larger than or equal to 0. Function is continuous, by the way. So this is x larger than or equal to 0, so the function is just this one. But if x is negative, then every absolute value becomes minus x. So you have minus x e to x. Right? So that's another way of expressing this first function here, right? Okay. Then the first method we're going to use is to use direct integration like this, right? So first, we're going to assume that x is smaller than 0. So any number which is smaller than 0. Okay? Right? Then, if we integrate, that's f, capital F. If we integrate from -1 to x, a negative number, the function f, well, in the negative side, the function is like this. So this is just minus the integral from -1 to x t et dt. And just using t here, not to confuse with the x that we put here, right? Well, it's like, by the way, I should have done the same thing here. So let me just change that, right? So I'm going to write here t, okay? And dt, t et, just to avoid confusing one variable with the other, right? This is the integration variable, this is the upper limit, okay? All right, so we have this, and then we integrate this by parts. So what we have is minus t et minus 1 and x, right? And then minus, so with this minus is a plus, the integral from -1 to x, the derivative of t, which is 1 times et dt, okay? So when t is x, this is minus x ex, and when t is -1, this is 1, so we're subtracting 1 times e minus 1. Okay. Then we have to add the primitive of this, which is et, substituted at -1 and x, and that is minus x ex minus e minus 1 plus ex minus e minus 1. Okay, so we have 1 minus x times ex minus 2 over e, 2 times e minus 1. Okay, so this is the primitive as long as x is smaller than 0. Now, what happens if x is larger than 0? Well, larger to or equal to 0. Actually, since the function is continuous, we can say that this is valid even for 0, right? So what happens if x is larger than 0? Well, if x is larger than 0, well, let me just to make it consistent with this, this is going to be like this. Doesn't matter much, but it will help now. Okay, so we'll define this like this. So x is larger than 0 now, and then we have to calculate capital F using the same integral from -1 to x ft dt. Now the problem is, in this interval, the two definitions of the function appear. So what we have to do to avoid confusion is to separate out the interval where the function is defined like this. So here you have minus x ex dx, or if you prefer t, Let's use t. Doesn't matter because now the two limits are numbers. But anyway, just to make it consistent, the notation. So we have t et dt, right? And then we have to add the integral from from 0 up to x. Okay? So we are splitting the interval minus 1x into the interval minus 1, 0 and 0x, right? And then we are separating, well, in the two pieces, the function is different, right? In this piece here, this is t e minus t dt, right? Okay, the calculation of this is just substituting 0 in this expression here. So if we do that, this is 1, this is 0, so this is just 1. So we get 1 minus 2 over e, right? So we just have to integrate this one, and we do this by parts. So if we integrate the exponential, this is minus the exponential, so it's minus t e minus t from 0 to x, right? And then we have to subtract, and with this minus you have a plus the integral from 0 to x. The derivative of t is 1, and then we have just e minus t dt. Okay, so this is minus x e minus x minus 0. All right, sorry, I've forgotten this constant here, so 1 minus 2 over e, and then as I said, this is minus x e minus x. When you substitute the upper limit, in the lower limit this is 0, so that's it. And then we have to integrate this one, which is just minus the exponential, because there is a minus here, right? And then you have the limits 0 to x, right? So we substitute here, and then we have 1 minus 2 over e, then minus x e minus x, and then here you have minus e minus x plus 1, okay? Because when you substitute here at 0, then you have 1, but you're subtracting, so with this minus, it makes a plus. So finally, in this region, what we have is 2 minus 2 over e minus 1 plus x times e minus x. All right. Now we can put both pieces together. So f of x is equal to 2 minus 2 over e minus 1 plus x e minus x when x is positive, and this one here, so 1 minus x e x minus 2 over e when x is negative or 0. Just a check, with a simple check we can make, we can check that this function is continuous. The check is we have to substitute here x by 0 and also here. So if we do that here, this is 1, this is 0, so this is 1. So 1 minus 2 over e is what we get here. And here you have, again, this is 1, this is 0, so that is 1. 2 minus 1 is 1, 1 minus 2 over e. So it's exactly the same result, up and down. So this function is continuous as it should, right? Okay, this is the first method. The second method is, okay, you take the same function here, right? So let me copy it down here. F of x is x e x, sorry, is x e minus x minus x when x is positive, and it's minus x ex when x is negative or 0, right? Okay, then what we're going to do is to calculate two separate primitives, one of this function and one of this function, right? So this function here which is a primitive of the global function f, must be a primitive of this and a primitive of this, right? So we write these two primitives. Let's call them f1 or f plus and f minus. Okay, and f minus. So let's see what they are. F plus is a primitive of x e minus x, which we do integrating by parts, and then it's minus x e minus x, minus minus plus, right? The primitive of e minus x dx, which is minus the exponential, so what we have is minus 1 plus x times e minus x, right? And of course, we have an additive constant, right? Now the second primitive is the primitive of this, okay? Integrating by parts again, you have minus x ex minus, with the minus is a plus, the primitive of ex dx, okay? And you calculate the primitive of this, which is just the exponential, and then you get 1 minus x e times e to the x. And then you have an additive constant, which of course need not be the same. Now you want the function to be continuous because you're integrating a function and the result is always a continuous function. So f plus of 0 must be equal to f minus of 0. And that implies, substituting here, this is minus 1 at 0, minus 1 plus c is equal to 1 plus c prime. So c prime is equal to c minus 2. Alright, so we can put here c prime, can remove this here and put simply c minus 2. And now c is the same constant in both cases, right? So, but what is this constant? Okay, how do you determine this constant? What else do we know about the function capital F? Well, we know something. We know that if we substitute x by minus 1, then we have the integral from minus 1 to minus 1, and that integral is 0. So we know this particular value of this function. So if we substitute at minus 1, we should get 0. Okay, we will apply this here and take the function at minus 1, right? So f minus 1. Of course, this is negative, therefore we have to substitute this function, right? Because in the negative side, this is what the function is defined as. So we substitute here, and then we have, for minus 1, we have 2, e minus 1, plus c minus 2. And that must be 0, which means c is equal to 2 minus 2 divided by a. So we put it here, 2 minus 2 divided by e, and here we do the same, we substitute this and we get just minus 2 divided by e. Minus 2 divided by e. Okay, we go up here, compare, we have obtained this in the negative side, and we have obtained this in the positive side, and both coincide as expected, right? So these are the two methods that you can apply to calculate this function. If it is convenient to apply one or the other, it's up to, well, depends on the problem, right? But in general, I'm going to use the second because I think it tends to be faster in all cases, right?